Welcome back, all you talented data scientists. So what we'll be talking about today is the multiplicity in polynomials. So if we take these two polynomial expressions, and you can see that they have been factorized, and if we go and plug those into a graph, we can see P1 follows the red line, and you can see we intersect through 1, make our way up and down through 2 and then through 3, while on the right hand side P2 is slightly different, similar shape, but it makes its way up there. The intersection is a little bit higher, makes its way down there, but you can see importantly it never goes below x equals 0. So what we want to do now is, firstly, in the previous video we understood how to get to our zeros. So once we've factorized, we can figure out, well, if we plug in 1 there, this is equal to 0. If we plug in 2 there, that's equal to 0, and 3 there, that is equal to 0. In this polynomial, we can see that if we plug in x1 on that term, while on this side it is 3 as well as 3 there. So this is where it now gets interesting in terms of the multiplicity. So what we can do now is put a basic table together, and what we can do is just write out our zeros, and we can have a column for multiplicity, and we can do the same thing over here, but you can see we've only got 1 3. There's 2 3s, but it's just a 1 and a 3, so we can actually write those in. So when we then go and fill in our multiplicity column, we can say, well, there's one of the 1s, there's also one of the 2s, and one of the 3s. So you can see for each of these the multiplicity is 1. Now it might be more, depends on the polynomial, might be less, but the point is there's only one of each of these terms. For P2, however, it's slightly different. We have 1 on this for the 1 term, while we have 2 for the 3 terms. Okay, scratch that. Let me start P2 again. Okay, on your marks, get set, go. All right, if we have a look at P2, it's slightly different. If we look at our 1 0 and our 3 0, so we have one of these, while we have 2 3s. So for each of these x values now, we can see the multiplicity. So what's important here now is if you have an odd number, then there's a sign change. If you have an even number, then there's no sign change. So we can see for P1, every time x is equal to the result of that particular term is equal to 0, we cross, say, from the negative into the positive range, and then we make our way down. And again, when we hit it now at 2, again, that is an odd number, so we cross again down into the negative side. While we make our shape coming around, we hit number 3. Again, 3 is odd, so we cross through it and we make our way up. Now that's a different story to P2. P2, you can see for where 0 equals 1, it's an odd number, the multiplicity, so we cross through it. As we make our way down, so we're in positive territory. As we now hit the 0 again for 3, this time it's an even number, so you can see we don't cross down into negative, we actually continue, and we just turn around, but we stay up on the positive side of the graph. All right, so hopefully that gives you a good indication on how to work out multiplicity and to decide at that particular 0 what's actually going to happen to the graph. Thank you.